Hi there, I'm Scott Lowe with ActualTech Media, and I'm here today at DriveScale, where I'm joined by Gene Banman, who is the CEO of the company. Gene, thank you for having us in your offices today.
Great to have you, thank you.
So tell us a bit about DriveScale. What do you do?
So what we do is orchestrate computer system platforms in the data center using industry standard protocols and networking. The vision of the company was really that components of computers have become so commoditized and that the networking has become so low latency and high bandwidth that we could actually disaggregate these commodity components, use software to put them back together to create the kind of computing platform you need for that particular application. And then as the application flows change, you can reconfigure the system and make it appropriate for the new requirements.
And you're calling it Software Composable Infrastructure.
That's what we call it, yes.
So you're a software company that's leveraging really commodity hardware that's become really quite powerful today to help people do better with their workloads.
That's right. And basically to orchestrate the compute platform within the data center is a data center-wide orchestration suite of components, of software components that allows you to build your compute platform on the fly.
And why would I want this as a customer? Why can I not just go build something traditional and call it a day?
Well, the kind of applications that we're targeting are so-called distributed applications, where you run one large application on hundreds or even thousands of commodity servers with, traditionally, they had their storage embedded. You had to configure these servers at purchase time, and then they were fixed for the 3-year, 4-year life of the computer, where the application flows that were sitting on top of these computers were not fixed for 4 years. And so people over-provisioned these computers because they never knew what was going to come on top of them. Often these computers are only being 25% utilized, but they wanted to make sure that they didn't run out of capacity. So with our system, you can always change the configuration. You can add resources where necessary. So you don't have to over-provision at first. You can upgrade just the parts that need to be upgraded. And you can also separate the life cycle of your storage and compute. You can upgrade your CPUs every 2 years and keep your investment in drives and flash around for 6 or 7 years. So just gives you much, much better utilization of the infrastructure that you've bought. It makes it much more responsive to changing user requirements. And because we've developed the software to be really very easy to use and transparent to the application, it's easy to deploy this.
So what's a common use case? When you have a customer that says, I need to talk to you about what we're doing, give us an example. Give us an example of a customer, if you can, that has bought the DriveScale solution and what it's done for them from a financial and a business standpoint.
So one of our customers is an ad tech company called AppNexus. They have a large Hadoop cluster that runs an index of their data set every day. 90 days of search history, and every day they add 24 hours of new data, and get rid of the 91st day and re-index that entire data set. The index then goes on to a transaction system that sells advertising in real time. They've been very innovative in improving the kind of services they provide to their customers, and their workflows are changing every few months, not every year or even every 3 years. And so they really felt like they had to over-provision. Their typical deployment was 20 drives per node. When they've gone to us, they've figured out they can get down to only 5 drives per node and get the same performance, knowing they can always add a 6th or 7th drive per node later. Also, they plan to hang on to these disk drives for 6 years and swap out their CPUs every 2 or 3 years. So they've been able to get much better utilization out of the hardware that they're buying and have better utilization over the life of the product.
You know, as you're talking, for whatever reason, an analogy sort of popped in my head about kids' toys. And you know, when my kids were young, you know, they had blocks and all this stuff, but you can only build certain shapes with a block. And it sounds like that's sort of what the traditional model looks like. But with PlayDoh, you can build whatever you want.
Exactly. We're the PlayDoh of the data center. Exactly right. That great analogy.
And so it's interesting that you can basically say whatever we need, we can build, and that's really I mean, as I think we talked about before we started shooting, that's really the future of computing, is this idea that we can really personalize our data center environments to exactly what our company needs. And it sounds like you're helping enable that pretty dramatically.
That's right. And there are new technologies coming along that are going to make that vision even more flexible. And I'm talking about Kubernetes and containers, where you'll have a data set sitting on a set of disk drives or a set of flash drives. And when you want to run the application against that data set, it gets fired up in particular servers by Kubernetes. Kubernetes talks to us. We attach all the drives that have that data set to those sets of computers, and the job gets run. When it gets done, those drives are disconnected from those computers. Those computers fire up another kind of application. A new data set is attached to those computers. And so basically, you get really optimized use of your investment. And your most expensive part of the computer center is the CPUs and the memory.
So, to storage, you're supporting, traditionally you've supported disk drives, but you've added support for flash now as well. And it's all still Ethernet addressable, but you can do something a little bit different with flash than you could with disk. Can you talk about that?
That's right. So, well, first of all, we could disaggregate disk drives with 10 gig Ethernet switches. That had enough bandwidth for the kind of slow data rates that HDDs have. But with flash, we need 100 gigabit switches. There's so much bandwidth coming out of a flash drive that we had to wait until the 100 gigabit switches became available. But the other thing going on with disk drives, we have to assign an entire disk drive to a server. If two servers were sharing a disk drive, the access actuator would be going crazy and performance would really go through the floor. But with flash drives, it's a random access device. We can slice it up into appropriate sized pieces, assign each piece or slice of the flash to individual containers. They could be on different servers. And so it becomes a much more flexible environment. Flash is still 10 times the expense of disk drives. But if you only need a gigabyte of storage, just take off a slice of flash and assign it to that particular container, and it's very cost effective. Yeah,
in fact, I was just going to say, if you don't have to assign an entire disk, I would imagine that the economics can work out as good as, or around the cost of disk on a case like that.
That's right. Maybe even better. And certainly you get the flash performance, which is massively faster than the disk drive.
Gene, thank you very much for this overview of DriveScale.
It was great. Thank you.
And thank you to our audience for watching this video.